All right, 4.3, continuing with our discussion of logarithms. So we've looked at the graph of the logarithm function. We've looked at the graph of the exponential function. We've talked about common logarithms. We've talked about natural logarithms, domains and ranges of exponentials and logs. So now we're going to use some properties of logarithms to manipulate logarithmic expressions. All right, so let's list the properties. We have what we call the product rule, which says if I have the logarithm of a product of anything times a times b, and this extends to more than two factors. We'll just use two factors to illustrate. The logarithm of a product can be broken up into the sum. Let me write this over here because I want to compare it to exponential rules. Because again, remember, logs are exponents, so it's good to see the connection between the properties of logs and how they connect to the properties of exponents. So the product rule says logarithm of a product can be written as the sum of the logs of the individual factors. And think about how similar that is to when we multiply same base, different exponents, we add the exponents together. Okay? Remember, logarithm is an exponent. We take the logarithm of a product, we can break that into the sum of the individual logarithms. Very similar to the rule of exponents, where we multiply same base, different exponents, we add those exponents together. So that's called the product rule. And we have the quotient rule. Quotient rule says if we have the logarithm of a quotient, we can break that up into the logarithm of the numerator minus the logarithm of the denominator, which again we can equate to when we divide same base, different exponents, we subtract the denominator's exponent from the numerator. And then we have the power rule. And the power rule says if I have the logarithm of something raised to an exponent, I can take that exponent and put it out in front of the logarithm. And that's going to be similar to when we take one exponent and raise it to a second, we multiply those exponents together. Okay, so we're going to use these rules, product, quotient, power rule, to go from the left-hand sides here. We give it an expression in some form on the left side. We want to, if we go from the left-hand side to the right-hand side, we call that expanding a logarithmic expression. We're expanding this from this to the sum and or difference of individual logs. That's called expanding, going from this to this. And we also want to go from this back to this. That's called condensing. So if we're given an expression that has sums or differences or multiplications in front of logarithms, if we go back this way, it's called condensing into one log expression. If we expand, we're going from the left to the right. So that's what we want to look at here in 4.3. Okay, how about number 8? Start with an easy one. Yeah, I'm going through this chalk. It's really good chalk, but it goes fast. All right, number 8 on page 477. We are expanding use logs to expand these expressions. So here we got a logarithm base 9 of 9 over x. Okay, we are asked to expand this into sums and or differences. So here we see we have the logarithm of a quotient. So we're looking at this property here, logarithm of a quotient, we can break up into the difference of the logarithm of the numerator, logarithm base 9 of 9 minus logarithm base 9 of x. Now we want to keep simplifying as much as we can. So when we see this, this was one of our special properties, right? We have logarithm base 9 of 9 to the first. Remember that was one of our special properties. This just equals the number 1, right? So if you see something like this, use those special properties. So this is now just 1 minus logarithm base 9 of x. And that's expanding this one log expression into sums and, or in this case, a difference of two log expressions, one of which simplified down to a constant. All right, so that's what we're doing. Let's look at a few of these. About number 14. We'll leave these up here to refer to. So number 14, we see this ln. So let's deal with that. So ln, remember, is logarithm base e. So you want to get used to using the ln. I mean, you can rewrite it as log base e, but ln, it's going to show up a lot, so you should get used to seeing ln. ln just means log base e. So once again, this is a quotient. So we're going to say the natural logarithm of the numerator minus the natural logarithm of the denominator. And now this, remember we looked at this property. We said log base b of b to the x equals x. Well, that is analogous to natural log of e raised to the x equals x, right? Because this is log base e of e to the x, log base e of e to the x. It's just this form for the Euler's constant. So if you had natural log of e raised to anything, that answer is just whatever that exponent is. That's what we have here. Natural log base e, e to the fourth. So that's just going to be 4. And there's nothing we can do with the 8. All right, what else? Number 42. All right, so in those two cases, we went from one log expression to sums and differences, and then simplified as much as possible. Number 42, we're going in the other direction. Page 477. We start with the sum of two log expressions. And we are asked to write this as 1. So when we condense, we're not done until we just have one log expression. Here we have 2. So we want to condense this, to one log expression. And then sometimes it's going to be one of those special cases. Sometimes it'll just end up in being a number. As I look at this, I think that's probably going to be the case here. But let's look at it. So here we have a sum, so we're looking at this case here. Same base, right? We have the same base, there's no base written, so we know it's base 10. So we have log base 10 of one number plus log base 10 of another number. So we can now combine that into this. So that's what we're going to do. Take the logarithm of, and I'll write it out, 250 times 4. Going the reverse from right to left of the product rule. 250 times 4 nicely is 1,000. Again, you don't want to stop here because you want to notice 1,000 is a power of 10. So we can rewrite this into one of our special forms. Right? 1,000 is 10 to the third. So now we have log base 10 of 10 to the third. And we know that answer is just. All right, so always simplify as much as you can. Remember, no base means base 10, and you know, any power of 10 you want to reduce as much as possible. All right, about 48. All right, everything we do, you know, just you get better with practice, right? The more you practice this stuff, the easier it becomes. Let's look at number 48 here. Log base 3 of 405 minus log base 3 of 5. 40, nope, sorry, it's not 48. Log, which one was that? I guess we could just do that one. Where did I get that? That's 46. Let's do 46. Log base 3 of 405 minus log base 3 of 5. All right, so here we have a difference. So we're looking at this case here, and we're going to go back to here. This one looks too easy, right? So we're just going to get 405 over 5. So let's see, 5 goes into 120 times 4, so that's 80, 81, right? Log base 3 of 81, 405 over 5. And again here, we want to use our special property and realize that 81 is what, 3 to the 4th, I think, right? 3 times 3 is 9, times 3 is 27, times 3 is 81, right? So we can rewrite this as log base 3 of 3 to the 4th and get our answer to be 4. So you want to do, if you got this far on a test, you get most of the credit, but if it said simplify completely, you want to make sure for full credit, you're going to go down to that last step. Okay, what else we got here? Okay, so we expanded, we contracted, we talked about the product quotient and power rules. So the last thing is change of base formula. So remember, I mentioned this a little while ago, and we said the only values we have on our calculator are log base 10 and log base e, right? So on our calculator, we have log, log, which is log base 10, and ln, which is log base e. So we want to convert any log to one of those two in order to find out the actual values. So the change of base formula says if I have logarithm, I'll use the same letters as the book here so I don't confuse you. And this is on page 475. It says the logarithm base b of m is going to be logarithm base 10 of m over logarithm base 10 of the base, or natural log. Either one works. All right? Either one of these, given this, you can use your log button on the calculator to get the value, or you can use the ln button. Either way, you're going to get the value. So, for example, you got logs on that calculator? Try to use ones that are already here. I can use this one, so I already got the answer. So here, if I say logarithm base 7 of 2506, you know, first you're going to see if you can convert it to one of our special forms, right? But 2506 is pretty apparent that it's not going to be a power of 7. If it was 49 or the 240, whatever the 7 cubed is, then you would use the special property. I mean, this will always work. If you can't see a special property, even if it does exist, if you use this, you'll get that number. But for something like this, there is no special property that will work. So we can either use, again, the log button or the ln button, either one. I generally go with the ln button. And the way to remember which one goes in the numerator, remember this is a base, that goes in the denominator. Right? That's how I remember it. So you take ln of 2506 over ln of 7, or LOG of 2506 over LOG of 7. Either one will work. Plug that number into your calculator, divide by that number, and you should end up with 4.02. Now also, remember how easy this is going to be to check using our definition of logs. If our answer is right, and what this is saying is we're looking for the exponent that if I put it on 7, I get this number. So if this is the exponent, to check, I'm going to say 7 raised to the 4.02, and that's going to come out somewhere close, depending on if we rounded it all here. But you should get a number very, very close to 2506. And that's the change of base. Is there anything else here? All right, let's do one. Well, actually, the other one is just using base 10 or base E. Either one you use, ln or log, you should still get this same number, and then the check should work. All right, we're good.